The muscle can contract in different ways, and we're going to, during the next 5 minutes, discuss the three different ways in which a muscle can contract. So the muscle is going to do one of three things while it is working. It's either going to be strong enough to overcome the resistance, which is called a concentric contraction. It is going to be equal to the force that is on the muscle, equal to the resistance, and that's called an isometric contraction. Or the force of contraction is going to be overcome by the resistance, and that is called an eccentric contraction. So looking at the first type, a concentric contraction, if you imagine yourself picking up a light 5-pound dumbbell and doing some curls with it, every time you decrease the angle of flexion, you are performing a concentric contraction. So that means the origin and the insertion of the muscle will come together, the muscle length will shorten, and you are exhibiting action. So biceps contract concentrically during the flexion of the elbow, simply lifting a weight. And that's the example of you bending your arm. Now in the coloring book, this is highlighted and it is called contracted. So that is a concentric contraction, shortening of the muscle length. An isometric contraction still involves muscle contraction. So you're still applying effort to the muscle. And considerable tension may be developed in a muscle, but no movement is actually produced. So if you were holding a weight that was as heavy as you could hold and you were holding it steady, you are applying contractile force to the muscle, but the origin and the insertion of the muscle are not changing their distance. So the weight is not coming out, it's not coming in, it is being held steady. And that is an isometric contraction. And a real-world example of that would be two arm wrestlers who are very evenly matched, both trying very hard to defeat the opponent, but no movement is actually occurring because the force of the contracted muscle and the force of the resistance are the same. Now again, in the coloring book, they're talking about a slightly different topic, so they're using the term relaxed to give you a visual of that. So an action where there's no movement occurring is called an isometric contraction. And the third type is called an eccentric contraction. So during eccentric contraction, the origin and the insertion of the muscle are moving apart. So even though you are trying to apply all the force you can to the muscle, the resistance is overcoming the muscular force you can create. So the movement, along with gravity, are pulling your arm apart. So the origin and the insertion are getting further apart despite the fact that you are trying to contract the muscle. So any controlled lowering where gravity would otherwise accelerate the movement involves an eccentric contraction. And again, think of the example where you have your arm bent at 90 degrees and someone is putting a heavy weight in your hand, stronger than you can flex or contract, but you then, in a controlled action, let your arm extend and set that weight down. So that creates a lot of tension in the muscle, and even though you are trying to shorten the muscle, the origin and insertion move further apart, not closer together. And again, in the coloring book, they define that image as stretched. So we have concentric, where the muscle shortens, isometric, where the muscle does not change length, and eccentric, where the muscle does get longer despite your efforts. Now, looking at grades of muscular contraction, you need to think of each individual myofibril, or each functioning thread in a muscle, as its own on-off switch. And you cannot partially contract a muscle fiber. It's either on and it's fully trying to contract, or it's off and it is relaxed. Now, partial contractions of muscles occur because you're only firing certain muscle fibers. So if we look at a simple diagram here of a muscle at rest, we have all of the individual muscle fibers relaxed. They are not trying to contract. If you picked up a light book from your desk, you're not applying full strength, you're only contracting a few of those muscle fibers. So you don't need to turn them all on, you will only turn on a few, and you will turn on enough to get the job done. Now, if someone asked you to try and pick up a 200-pound weight off the ground, you would then do your best to try and fire all of the muscle fibers at the same time. And it's your ability to synchronize these muscle fibers that plays a large role in muscular strength. The person who can apply the most strength probably has a greater cross-section, a larger muscle to work with in the first place, but that's not the only factor that applies to strength. If you can't effectively fire every single muscle fiber at the same time and synchronize that action, then you can apply more muscle strength. And a great example of that would be watching two teams in a tug of war. The strongest team doesn't always win. It's the team who can get all of the individual people in their group to pull at the same time. That's when you get the big movement in the rope. That's when you can put the other team off balance, and that's when you're applying the most force. Everybody pulling collectively at the same time will get your best result. And sorry, I didn't mention that back at the beginning. That is going to be on page 43 of your anatomy coloring book.